What's up, Chuckles? This is Mr. Schneider coming at you. As I said, we're at the end of chapter 8, so I wanted to go over one of the common problems I saw from 8.3. Now, typically in the other ones, I didn't see a lot of issues with like homework or your homework quizzes. It's pretty straightforward. You're putting your null and alternative hypothesis out there, you're finding your p-value, and then you're using the decision rule, which you know well and good. But 8.3 was a little bit different because we didn't use the two, even though we had, sorry about that, we had two, we still have two samples, but they're linked, they're paired in a way. Okay, so it's kind of like before and after. So we had to do kind of a weird way. The book kind of does a little bit weird. That's why I put the other supplemental video up. And the professor went over this issue there, but maybe you needed me to call it out when you saw it, or if you didn't look at it and you tried to use the book, I would watch those videos. Let me see what we got on my views here. I got my YouTube page up. Yeah, I only have one view on those, so you guys need to view those. Go ahead and view them. It's great. So the issue that we have is a lot of people, when they set up their null and alternative hypothesis, had the opposite, what would it be, inequalities, the opposite inequalities of what they should have gotten. And here's why. It's a little bit counterintuitive of what's happening here. So I'm going to draw up sample 1, and we're going to say the amount of clowns. Wow. It doesn't get any easier, folks, to write this stuff. Sample 1 is going to be the number of clowns in a certain city limits of the suburbs of Phoenix. So let's say in Chandler, we have 2 clowns per day that are just roaming the streets. Let's say in Phoenix, we have 3, Ahwatukee 1, even though it's still Phoenix, but we'll count it for this sample. It's just an example. And then let's say Gilbert, we have 2, and Scottsdale has, I don't know, maybe they're anti-clown. They just have 0 clowns running through. Okay, so that would be our sample of those cities there. And what happens is, let's say that you and I, we are creating some sort of potion or elixir that is we want to increase the clowns that appear in these cities. So we have this, we're gonna make this elixir, and we're gonna sprinkle it all over all the cities. We're gonna rent this giant plane. It's just gonna sprinkle over. People think it's rain. They'll look up and be like, oh man, what is that? But it's our elixir because we want more clowns, because clowns create that chaos. And as we know, chaos is a ladder. As our good friend Littlefinger would say, chaos is a ladder. So we want to sow this chaos from these clowns, the increase of clowns. So I don't know why I put sample 1. It's going to be the same sample, but we can say before, after. Let's just say sample 2 is after. After our elixir happens, and our claim to people is that after we sprinkle the elixir, clowns go up. So after we sprinkle the elixir, let's say, I forget what this was. I think Chandler goes from 2 to 4. Let's say in this area, I think that was Phoenix, it stays the same. Let's say that, Ahwatukee goes from 1 to 2. Let's say this actually goes down for Gilbert. But in Scottsdale goes 4, goes from 0 to 4. Okay, so that's before the elixir, after the elixir. So one of the things that happens for us is we say, or you guys say when you're doing that, all right, how do I set up my null and alternative hypothesis? The claim is going to be we made this elixir to have it go up. So why am I getting it wrong? We only have about 30 seconds left, or 20 seconds, so I'm going to cut this short, and then I'm going to come back to that question in the next little guy, okay?